Alright, ladies and gentlemen, this is going to be our next video, and we are going through and continuing upon photosynthesis, specifically looking at the Calvin cycle. Let's get started on this next video. So we're looking at this half of the reaction now, or this side of the chloroplast. And what we're specifically looking at is the Calvin cycle. So we're looking at light-independent reactions because they don't require light anymore for the energy. So the Calvin cycle is going to go through, and we're taking carbon dioxide molecules and we're going to run them through this cycle, and via this cycle what we're going to generate are sugar molecules, specifically glucose. So this is occurring in the stroma. Remember, light reactions, or the light dependent reactions, occurred in the thylakoids, and they generated ATP and NADPH to power our Calvin cycle. And now what we're doing is the hard work. We're taking the carbon from the carbon dioxide and putting it into the sugars. So what is the Calvin cycle? Well, the Calvin cycle is where plants use chemical energy, the ATP and the NADPH, generated via the electron transport chain to build carbohydrates, these sugars. And it was named after this American scientist, Melvin Calvin. And he really came up with the inner workings and figured out how this cycle functioned to go through and produce the sugars in the plants. So the key thing that we have to understand here is we're taking carbon dioxide, CO2, and we're going to take the atoms of that CO2 molecule and we're rearranging them into glucose. So this here is our carbon dioxide, and we're taking this and we're rearranging it into C6H12O6, which we call glucose. Now the structure, remember, it has this hexagonal shape here. Kind of remember this from the biochem unit. And it's going to consist of carbons, which are here, 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 and here. So each one of these is going to be a carbon. And then it's also going to consist of our CH2OH group here. And then we also have our HOH group here. And another OH, H. And these are getting really difficult to see, I apologize. HOH. So we're creating this really complex structure that consists of 6 carbons. So if we think about this, we have to take at least 6 carbon dioxides to go through and produce one of these glucoses here. And we have to understand that we're breaking the bonds here and rearranging those bonds and putting them into this hexagonal structure, which we call glucose. So it's a rearrangement of all the molecules that you're going to go through and see. So when we piece this together, it's a rearrangement of all of these carbon, oxygen, and hydrogen molecules that we get from photosynthesis, from the water, and then also from the air, from the carbon dioxide, and we rearrange them and put them into this glucose. So let's go through and delve into the Calvin cycle now. Now the first thing that we're going to do is we're going to input 3 CO2 molecules. So you have 3 carbon dioxide molecules. Now we're going to represent each one of these carbon molecules with one of these orange spheres here. And this entire process, the Calvin cycle, is also referred to as carbon fixation, because we're going through and fixing carbon in this new molecule. So we're going to take an enzyme, and the enzyme that we're going to use is Rubisco. And Rubisco is going to take these 3 CO2 molecules. Now, during this fixation step, what we're going to get is a molecule with 3 carbons, 2, 3, and it's going to be called 3PGA. Now, at the end of this, we're going to go through and fix a phosphate group. So we're going to have this phosphate at the end of this PGA molecule here. And this is what we call the first carbon fixation step. Now, we're actually going to get, and this will make a little more sense, is we're going to get 2 of these molecules. So there are 2 of these molecules total. And these are going to go through and feed down. And what they're going to turn into is this G3P molecule. We're actually going to go through and produce 6 of these total. So there's going to be 6 of these G3P molecules. And 5 of the 6 G3Ps, so we're going to have our 1, 2, 3. So 5 of these G3Ps goes back into the Calvin cycle. And then of the 6 that we have, only 1 G3P actually goes out. And this G3P is what we turn into glucose. So we turn that G3P into glucose. Now this entire process is going to require energy. So throughout this cycle, we're converting ATP into ADP. And then we're also taking NADPH and we're converting it into NADP+. Remember, when we go through and use up that phosphate, we break that phosphate or break off the hydrogen, the electrons, it's producing energy to power this cycle. Now we're also going to go through and use ATP here. So we're converting ATP into ADP here to release our energy to power the cycle. And we're going to go from 5G3P. These are the ones that are recycled. And we call this step here the regeneration step, because we're recycling 5 of the 6 G3Ps, putting them back into the Calvin cycle to get 3 molecules of ribulose biphosphate, which consists of 5 carbons put together with the phosphate attached to the end. So at the very end of this, we also have a phosphate, and we have a phosphate here. We'll go through and put a circle around it for the phosphate. Now, we're taking this RUBP, or ribulose biphosphate, and we're combining it with our CO2 molecules here to get 2 molecules of our PGA. Remember, we're getting 2 of these PGA molecules, and then we're using the energy to power this Calvin cycle. Our whole goal here is to produce 1 G3P, which we will eventually turn back into glucose. But this entire process has to go from here, carbon dioxide, through each of these steps in order to get to our final product of glucose. So the end result of all of this photosynthesis, the light-dependent reactions and the light-independent reactions, remember we call the light-independent reactions the Calvin cycle, and we can refer to the light-dependent reactions the electron transport chain. When we put them together, what we get is sugars. And we take that sugar, and sometimes plants are going to use it for maybe structure in their actual body of the plant. But that sugar is then going to be sent to the mitochondrium, and the carbohydrates go through and they store that energy. Remember, it's short-term storage. They're going to use that energy, store it, and then when the energy is needed, then they can send it to the mitochondrion to be used for producing chemical energy. So, did you guys learn? Well, did you learn a couple of things? Did you learn about the Calvin cycle? Did you guys learn how chemical energy powers the Calvin cycle? And then did you guys learn about how sugars are made? This was a lot of content via the Calvin cycle. It's really important that you don't get hung up in too many of the details, but kind of understand the fundamental basic parts of that Calvin cycle and how we're going through and rearranging those carbons. So this is going to be the end of the video. I will see you guys in class tomorrow.